four factors of a gas that affect it. Define the term and give the unit for each of the factors. All right. Joshua. All right. Achilles. Where are you at? Yep. Shenza. Pierce. Jack. Irving. There you are. Gosh. 2, 4, 6, 8. Are you not? Yeah.
I mean, the drums.
All right, ladies and gentlemen, questions before we get going today. Okay. Unit test Thursday, the 18th, ladies and gentlemen. That's 2 days from today, so we got a lot to do. So, name me one of the four factors that affects a gas, Joshua. Good. Now define temperature for me. Well, I'm glad you started defining something and then you couldn't finish it.
Average kinetic energy.
More. So just average kinetic energy. Any average kinetic energy.
Of a substance.
Of a substance.
Of a particle.
Of a particle.
Yeah.
Of a particle.
Of love particles.
The particle's where?
Any particle.
Any particle. Grab a particle anywhere. That's kinetic energy. Come on, think about it. You've gotten over half the definition. Temperature is the average kinetic energy. Where?
I wrote it down.
By the way, this is on your test. That's the reason I'm going over it. Was a question on your first quiz. One that a lot of you struggled with. So I thought maybe it would be a good idea to go over it, get it down. Maybe some of you were sitting there going, I have no idea. We maybe write this down. Have it so that you know it when it comes time on the test. But okay, maybe not. So let's go back. Shenza, you want to try again and give me the full definition, or have you gotten as far as you can go? Okay. So temperature is the average kinetic energy in the particles of matter of a substance. Whatever substance you're talking about, in this case, gas. Okay, good. Pierce, give me a unit for temperature. Calvin, give me another unit for temperature, Angel. Degrees Celsius, yes, very good. Give me another factor that affects a gas.
Volume.
Volume. Volume. What is the definition of volume, Jack? The amount of space something occupies. Give me a unit for volume, Faith. Give me a unit for volume, Skylar. Liters. Give me a unit for volume, Josie. Cubed one. Oh, thank you. Cubed one.
Centimeters cubed.
Centimeters cubed. Thank you very much. All right. Stephen, give me another factor that affects a gas.
Pressure.
Pressure. Define pressure, but I want the KMT definition of pressure, Christopher. The kinetic molecular theory definition of pressure, not force divided by area. Irving, definition of pressure. Not that one. You are correct. That is a definition of pressure. That is not the one I want because that is not the one that applies to gases. Jaden. Nope. Josie. No. You guys keep going back and giving me that one. That is a definition of pressure. I want the gas definition of pressure.
How many times he comes?
What?
How many times he
Close.
How many times particles with the walls?
Close.
How fast?
The constant bombardment of particles on the walls of the container. That is what pressure is. The constant bombardment of particles on the walls of the container. Joshua, give me a unit of pressure. mmHg. Morgan, give me a unit for pressure. KPA. Ariana, give me a unit for pressure. Caden, give me a unit for pressure. ATM. Okay? So those are our units for pressure. We have one more variable. What is the last variable, Achilles? What? Not number of gases. What does N represent? No, it does not represent mole. What does N represent?
The amount.
The amount of substance. The amount of substance. Okay? N is the amount of substance. Eric, what is amount of substance?
It's number of particles present in the gas.
The number of particles present in the gas. What unit do we measure that in? What unit do we measure that in, Maddie? The amount of substance. Moles. It could also be in what other unit, though?
Foreman.
It could also be in grams, and we could convert from grams into mass, mass into grams, ladies and gentlemen. Questions? Okay. So again, ladies and gentlemen, a little bit of reviewing, a little bit of new stuff, going through some things, and I want to get you some time in your gas law packets today. So with that in mind, ladies and gentlemen, let's go to our EISN and let's go to slide number 58. This is where we left off the other day, ladies and gentlemen. Now, we had gotten through this. Two gases under the same set of conditions, meaning that they are at the same volume, same temperature, same pressure, same number of moles. Have the same kinetic energy. Why? Because they're at the same temperature. Kinetic energy is equal to 1/2 mv squared. That is the formula for kinetic energy. I'm not making you memorize this formula, but we are going to apply it. Is equal to 1/2 the mass of the second gas times the velocity of the second gas. Maddie and I run a race. We finish with the same kinetic energy. Who wins?
Matt.
Why?
She has the smaller mass.
She has a smaller mass. Therefore, she has to have a larger what? Speed, velocity. She has to have a greater velocity to make up for the lack of kinetic energy she has comparing her mass and my mass. She needs to make that up in velocity so she will move faster. What does that mean for gases, ladies and gentlemen?
The lighter gas.
The lighter gas wins. The lighter gases are always moving faster than heavier gases at the exact same temperature. Okay? At the exact same temperature, a lighter gas will move faster than a heavier gas. So literally, you open two containers, you smell the lighter gas first if there is an odor there. Yes?
So the weight of a gas would be determined by its density?
No. The weight of a gas is determined by its molar mass. By its molar mass. Density is different. Density is mass divided by volume. We're just worried about mass. So, to find the formula mass of a gas. Noble gases, easy. Which one is the slowest noble gas? Don't call Agnesian down at the bottom. Which one is the slowest noble gas? Radon. Why?
It's the heaviest.
It's the heaviest. What is the fastest noble gas? Helium. Why? What is the fastest gas of all, ladies and gentlemen? Hydrogen. Why?
Because that's the lowest molar mass.
Lowest molar mass, even though hydrogen's a diatomic? What's that mean?
There's two.
There's two of them. What's the mass of each hydrogen? 1.01. What is the next smallest gas on the periodic table next to hydrogen? Helium. What's its mass? 4.0 something. Hydrogen, even though it's a diatomic, even though there will be two of them, is still a lighter mass than helium. It is the fastest moving gas on the periodic table. Yes, sir, go ahead.
So then when they're talking about gases being like heavier than air and flowing to the ground,
That is density and that is different. Okay? But please remember this. Any gas under the same set of conditions, we find its mass and divided by the volume, correct? Two gases under the same set of conditions. Now, density does not depend on sample size either, right? Density does not depend on sample size. So the least dense gas on the periodic table is hydrogen. Because under the same conditions, it will occupy the same space as any other gas. And actually, we could compare them based on STP. Using what for volume?
22.5.
So the lightest gas is going to be the least dense one. Hydrogen is the lightest gas on the periodic table. So it will be the least dense. Now, density is different. Density means that if you put them in a container, which one's going to be on the top, which one's going to be on the bottom. Speed is how fast they are actually moving. So again, gases that are at the same temperature have the same kinetic energy. Maddie and I run a race. She blows me out of the water because she's going to be moving a lot faster than I am for more reasons than just the fact that I have a larger mass. Yes, I put an M in front of that, ladies and gentlemen, mass. Okay? So, what it also means, though, ladies and gentlemen, is if we rearrange this formula, I get rid of the 1/2. Why would I do the same thing mathematically to both sides? Exactly. I just get rid of them. Why divide both sides by 1/2? I now get my masses on one side of the equation. Mass of B over mass of A. These masses are proportional to the velocity of A squared over the velocity of B squared. Okay? Now, I've taken mass of A and I've moved it to this side. I've taken the velocity of B and moved it over to this side, which means I'm dividing by it. That's where I get this formula from. Now, I'm not going to give you the velocity squared, but I may give you the velocity, which means I'm taking the square root of both of these and the square root of both of these just so that we do the same thing on both sides of an equation. Which means, ladies and gentlemen, that we literally could find how fast the gas is moving based on its mass. They are inversely proportional, meaning the heavier mass is going to be moving slower. The lighter mass is going to be moving faster. Now, the only way we can do this is if they actually give you a velocity. So that is what we are doing here. Find the velocity of hydrogen sulfide gas that is under the same conditions as carbon tetrachloride gas, which has a velocity of 1.45 meters per second squared. Now, ultimately in this problem, they're asking you to find the velocity of hydrogen sulfide gas. To do that, ladies and gentlemen, we're going to assume 1 mole of gases. Why? Because it doesn't matter what sample size we pick. 1 mole allows us to easily find the what of a sample? The mass. We can easily find the mass of 1 mole of a sample, assuming we can write what? A correct formula. So, we are going to use this formula. The square root of the mass of B over the square root of the mass of A is equal to the velocity of A over the velocity of B. I don't care, and it does not matter which gas you call gas A and which gas you call gas B. But if it were me, and I were solving for a velocity, which is what it's asking for, I would put it in this spot right here to make it easier to solve for. I would put it in this spot right here. Okay? Now, I do need the mass of the two gases. Well, gas A is hydrogen sulfide. Hydrogen sulfide is H2S. Sulfur is 32.06. Hydrogens are 1.01. 2 hydrogens, 2.02 plus 32.06 gives me a mass of 34.08 grams per mole. Anyone have any questions on this? Okay. Gas B is carbon tetrachloride. That's CCl4. Carbon is 12.01. Chlorines are 35.45. We take that times 4. Okay? That's about 100 41.8 something plus the 12 point something here, we get a mass of 153.81. Now, right away we know which gas is faster. What?
H2.
The hydrogen sulfide. Why?
And it's like
Because it's lighter. But we're actually going to calculate its speed. And the reason we can do that is because we were given the velocity of the carbon tetrachloride. So, carbon tetrachloride I'm going to put here in the velocity of B. That goes here. This is the mass of the carbon tetrachloride. Because look, B here and B here, correct? So I'm going to take the square root of 153.81. Yes, you're going to have to do a little math in your calculator. Divided by the square root of 34.08. Now, here's the nice part of setting it up this way, ladies and gentlemen. It makes my math a little bit easier. Normally, we would do what to this? We would do cross products are equal. But since velocity of A is on top, I'm going to shortcut this just a little bit here. What I mean by that, ladies and gentlemen, is to get this so that the velocity of A is alone on this side, I'm going to take this side times 1.45 meters per second. That will cancel these out. And what I do to one side, I do to the other. Again, if you can't do this mathematically, do cross products are equal. Put it all on one line. I don't think this is that difficult to math. It gets you everything on this side, ladies and gentlemen. It gets you VA alone. This is why I wanted VA to be the velocity of the hydrogen sulfide gas, because all I got to do is take this side times the number on the bottom. I set it up to make the math easier for myself. Questions? Okay, so again, here is this, same as it was, times the 1.45. Now, again, do your math correctly in your calculator, ladies and gentlemen. Hopefully you know how to find the square root key on your calculator, so that you can take the square root of 153.81 times 1.45 divided by the square root of 34.08. You can't use 153 and 34.08 here. You've got to take the square root of them. You have to. We end up with a velocity of 3.08. Now, the unit has to be the same as whatever the unit was to begin with, meters per second. Again, the unit on the top and bottom here have to be the same. The unit over here was grams per moles on both of these. Same unit. Questions?
and this is Graham's law.
This is called Graham's law. I'm not going to ask you whose law this is on the test. I'm going to give you a problem like that and see if you can use it. And by the way, I hope I told you this. I think I did. I will give you all these special gas law formulas on the test. Okay? So don't bother to write them onto your notes. Okay? I mean, you can put them on your periodic table if you want, but I'm going to give you a sheet with them. Questions? Okay. So, Josh was asking about this a few minutes ago. Okay? Well, there is a relationship between densities in a gas as well. Density is equal to mass divided by volume. It is an intensive property, which means it does not depend on what? Good, thank you, excellent. Intensive properties do not depend on what?
Sample size.
Sample size. Pick whatever sample size you want, okay? We could choose any sample size we want. With gases' densities, we could change the conditions because of temperature and pressure. So can volume change. But the only way we're going to compare gases is if we've got both of them at the same set of conditions. So what is the density of oxygen gas at 11.5 psi and 45 degrees Celsius? Well, we know what the amount of gas should be. What amount of gas should we select? 1 mole. Okay? Now what we can't select here is our volume to be 22.4. Why? It's not an STP. What that means is that even though hydrogen is the lightest gas of all, ladies and gentlemen, it is the least dense gas. Its density can change depending on the condition. 1 mole of gas could occupy different amounts of space depending on if you change pressure and if you change temperature. At STP, it's always 22.4. But if you move away from STP, its volume can change. It can become more or less dense. So we have to find the volume under the conditions that we are given. Now again, you can do this 2 ways. What are they? We've done these problems. What's the 2 ways that you can do them? How can you find the volume? Ideal gas law or what's the other one? Nope, but you're close. Ideal gas law or combined gas law? Combined gas law. Gay-Lussac's can't be used because we're also changing the pressure here. Okay? So we're changing the pressure and the temperature. Okay? So, what is the density of oxygen gas at 11.5 psi and 45.0 degrees Celsius? We could use combined gas laws and compare to STP. We assume 1 mole, P1V1T1 equals P2V2T2. Convert our 45 degrees into Kelvin, 318. Questions so far? Okay. Formula mass for oxygen, which we are going to need later on to find density, because its mass divided by volume is 32.0 grams per mole. We put in our conditions here, 11.5 psi, 318. I don't know what this volume is. Standard pressure, 14.7 psi. Standard volume, 22.4 liters. Standard temperature, 273. By the way, multiply all these together, ladies and gentlemen. Anybody know what we get? What is it? Don't multiply it. Tell me it.
8.31.
Nope, nope, nope. You're close. That's not KPAs. This is PSI.
1.2.
1.21. Had the right idea, Maddie. You just grabbed the wrong one. These numbers here are the R from ideal gas law. They are the R from ideal gas law, ladies and gentlemen, which 14.7, 22.4, and 273 becomes 1.21. Okay? Again, we are taking and isolating V1. How? By dividing both sides, or by multiplying both sides times 318, so it ends up on the top, and dividing both sides by 11.5, so it ends up on the bottom. Here's what we would get, ladies and gentlemen, for V2. It comes out to 33.4 liters. That is the volume of this gas. Okay, but what were we originally trying to find?
Density.
So how do you find density?
Mass over volume.
Mass divided by volume. 32 grams divided by 33.4 liters. That is the density of our gas under these conditions. Now, if this were at STP, what would that number on the bottom have been?
22.4.
So it would have been smaller than that 33.4, correct? So what does that mean the density would have been at STP? Larger or smaller? We're dividing by a smaller number, which means it would have been larger. Would have been larger. Okay? So literally, the density of this gas has gone down because of the conditions we have changed it to. The mass didn't go down. It just is occupying a larger volume because we have changed the pressure and the temperature, ladies and gentlemen. Questions? Now, if you're at STP, do we need to go through all of this? No. The density of any gas at STP can be found by doing what? Come on, we've been through this. Any gas at STP. What is the same for any gas at STP? What? Exact same volume. What's the volume at STP? 22.4. At STP, it's a much easier problem because we don't have to find the volume at non-standard conditions. We know what the volume of the gas is. It's 22.4. All right? Same problem, ladies and gentlemen. Just going to show it to you with using PV equals nRT. Still converting the temperature to 318. Formula mass is still 32.0. Here's our formula, ladies and gentlemen. Plug in the pressure. Volume is unknown. 1 mole. Our R value, 1.21. 318 Kelvin. When we take and we isolate V, we get the same answer, ladies and gentlemen. Did we get 33.4 last time? If you're off by a tenth, a little bit, I am okay with that. Why? There's rounding in these numbers, ladies and gentlemen. This is a rounded number. This is a rounded number. I'm not going to argue over 33.4 liters and 33.5 liters. Okay? Now we put it into mass over volume. 32.0 over 33.5 gives us 0.995 grams per liter. You want to put it into milliliters, that's 995 grams per milliliter. Questions? All right, now what happens if we compare two densities of a gas under the same set of conditions? What's the same about two gases under the same set of conditions?
Pressures are equal.
Okay, what else?
Volume.
More important for us, our volumes are equal. The volume of gas A is equal to the volume of gas B because they are under the same set of conditions, right? If we assume we have the same what of each gas? Same amount. And since density doesn't depend on the amount, we can assume the amount. What amount do you want to assume? 1 mole. Density is equal to mass divided by volume. All I've done is rearrange this. Volume is equal to mass divided by density, correct? The volume of gas A would have to be equal to the volume of gas B under the same set of conditions. Questions on that? You said they were at the same pressure, they're at the same volume, they're at the same temperature, correct? Okay. So what that means is that the mass of A over the density. Why? If volume of A is equal to mass over density, that means the mass of A over the density of A is equal to the mass of B over the density of B. Questions on this? Volume is equal to mass divided by density. That's what I've shown you here. So for gas A, it's the mass of gas A over the density of gas A. For gas B, it's the mass of gas B over the density of gas B. Now let's get this so that the masses are on one side, densities are on another. Therefore, mass of A over mass of B is equal to the density of A over the density of B. These are directly proportional. Why? Because A's are on top, B's are on the bottom. In our velocities, they were inversely proportional. Okay? Inversely proportional. So a heavier gas, what do we know about its density under the same set of conditions? What? No, I'm not asking for slower or faster now. Hydrogen gas, radon gas, same set of conditions. which one's density is more?
We don't.
Why?
We don't have heaviness.
Because its mass is going to be bigger. If you're going to have a bigger mass, you're going to have a bigger density. Okay? You're going to have a bigger mass, you're going to have a bigger density. The density of helium at 19 degrees Celsius and 98.5 kilopascals is 0.325 grams per milliliter. Or grams per liter, sorry. What is the density of nitrogen gas under the same set of conditions? Okay, tell me what I don't need in this problem. What's not going to help me solve it? What? The temperature. I don't care about that. Anything else?
The pressure.
I don't care about the pressure. Because these gases are both under the same set of conditions. So I'm going to use this formula. The mass of A over the mass of B is equal to the density of A over the density of B. Which gas do we not know the density of? Nitrogen. Do I want that to be gas A or gas B? I want to solve for the density on top. Just like we solved for the velocity, I want to solve for the density on top. Hello, Mr. Brand. Yep, I do. Okay, thank you. Bye. Maddie, Career Center. Yes, please do. I don't know how long it's going to take you. They just called. Okay, so, okay. So again, we've got the mass of the gases. You got to be careful. Why is this N2 and this just HE? Nitrogen is a diatomic. Helium is not. The formula for helium is NHE. Its mass is 4.00 grams per mole. The formula for nitrogen is N2. 2 times nitrogen, or 28.02. 28.02. She already did the pass, so you're good. Okay. So now I put my masses over here. Now, why did I do the 28 over the 4? So that I could have the density of the nitrogen, which I'm looking for on top. Okay? So again, I'm going to get dA alone, I'm going to multiply this side by 0.325, sorry. What I do to one side, I do to the other. That gets me the dA alone, 28.02 grams per mole times 0.325 over 4, ladies and gentlemen, gives me a density of 2.28 grams per liter. Are there other ways to solve this? You bet. Am I going to show them to you? Heck no. Just use this. It's the easiest thing. It's one of the formulas I will give you. Questions, ladies and gentlemen? Can't go forward anymore. What does that mean? Yep, means we're done. That's it. That's a gas law unit. Now, you need practice. And that's what I'm going to give you right now. Time to practice. Okay? So, ladies and gentlemen, you got your worksheets, especially the new one that I gave you with the special gas laws on it. Again, you got to recognize what information they're giving you if you're going to figure out which gas law to use. Shenzo, what can I do for you? You need help? I haven't even told you to go to work yet.
Okay.
Okay, go to work. Shenzi, you need some help?
Yeah.
I'll come over there then. Okay, ladies and gentlemen, let's go. Go to work.
Don't be sad it's over. It's not because it happened.
Now we have 4
Okay.
more problems. I never did this. Is that the first one?
Wait, Suzanne? I'll tell Suzanne.
Those guys, look at the paperwork if you do it, yes? Hey, how you doing? Thanks. That's it. That's all. Okay.
This is what we say.
Thank you.
Yes, 90 degrees. Now you can any of them. Just need to move any of them. That's it. Give me all the stuff. Good question. Great point. Yes, you should be able to do them all on that worksheet now.